Hey guys, this video is going to help with proportional relationships and tables. It's section 2.1 in the regular 7th grade course. First of all, we need to know what a proportional relationship is. What it is it's well, once we look at it more, it's like it has an equivalent ratio. Remember the ratios we were learning? So basically it reduces to the same fraction, so it's proportional to each other. So let me give you an example of what proportional is instead of writing a definition, because I think that'll make more sense. If I say I have two circles and a square, what is the relationship, the ratio between circles to squares? We have two circles to one square. So I'm going to write this as 2 to 1 ratio. Now, what if I have four circles and two squares? What is the ratio of circles to squares for this group? It's going to be 4 to 2. Now, if I look at those ratios and I reduce this fraction, do they have a proportional relationship? Are they equal? Do they reduce to the same thing? Well, 4 is divisible by 2 and 2 is divisible by 2. So if we divide 4 by 2, we get 2. Divide 2 by 2 and we get 1. So they both reduce to 2 to 1. We could also add one more example here. What if I have 6 circles and 3 squares? Right? So then this relationship or ratio would be 6 to 3. And again, they're both divisible by 3, so I can reduce this fraction to be 2 over 1. So all of those relationships are proportional. So they reduce to the same thing. They kind of go like into tables a lot in this section. So I want to give you a couple examples. This is like my first example of using a table with this. So let's say we are talking about squares, and we're going to have side length, and we're going to have the perimeter, and we're going to have the ratio of the perimeter to side length. So perimeter, side length, that S kind of side length, or maybe I should have used an L, what either way. So this is kind of going to be my table. And I'm going to say, okay, what if the side length is 1? So these are squares. I want to make sure we understand they're squares, because that makes a big difference. So if they're squares and their side length is 1, what's the perimeter all the way around your square? Well, it would be 1 plus 1 plus 1 plus 1, which would give me 4. So the perimeter is 4. What would be the ratio of perimeter to side length? That's going to be 4 over 1. I'm going to have to write the fraction a little sideways just because I didn't make my chart very big. And I don't want to rewrite it. Okay. So then the next one, what if I have a side length of 2? So again, 2, 2, 2, 2, all the way around, right? So we would go, if I draw a little square, each side's going to be 2, so it's going to be 2 times 4 for a perimeter around, which is going to give us 8. And our ratio is going to be 8 to 2, which if we reduced is 4 to 1. So that does equal 4 to 1 as well in there. Okay, what if my side length is 3? Then what is going to be my perimeter, right? So then we're going to go 3 plus 3 is 6, plus 3 more is 9, plus 3 more is 12. So we got 12, and my relationship is going to be 12 to 3, which does reduce as 4 to 1 as well. Let's just do one more. Let's do the 4. And again, 4 plus 4 plus 4 plus 4, right? 4 plus 4 is 8, plus 4 more, plus 4 more, and you're going to have how many? 16. And 16 to 4 is also equal to 4 over 1. So we sometimes when we're given these charts, we're just given this information here, and you have to decide if the relationship is proportional. Sometimes you have to just fill it in, and this one I just filled in. We can definitely see the relationship is proportional. They're all 4 to 1. Okay, so let's look at one where, let's see, that one is proportional. I was trying to think of one that's not proportional. Does show, does show. I was thinking there that they threw a couple. Yep, here's one that does not show. So I want to show one that doesn't show proportional, and I want to show it in the XY format. So let's see, we have 8 to 4, 7 to 3, 6 to 2, 5 to 1. Okay, so here's a chart. Oops. Here's a chart in like written as XY, whether they're boxes around it or however they write it. How would I decide if these are proportional? We always want to take Y and divide it by X. So our ratio is going to be Y to X. Always we want to go Y to X. I mean, you really could go X to Y as well, but we want to stick with the Y to X as much as we can. So this first one would be 4 to 8. So we'd have 4 over 8. The next one, which would reduce to 1/2, right? So both the top and the bottom are divisible by 4. The next one is going to be 3 to 7. And does 3 to 7 reduce to 1/2? No. So it's not proportional. So the relationship is not proportional. I can't spell proportional today. Okay, so not proportional. Let's see. Copies. How do you know? So all you're doing is dividing always divide the second one by the first one to find. I'm looking through your homework right now just to see if there was any, sometimes they throw like a trick at you a little. You're just filling in charts and you're just going to divide those ratios and decide if they are proportional. All right, hopefully this video helped.